Okay, so in this video, we're going to talk about evaluating trigonometric expressions of special angles, and that's pretty much the angles that are on this unit circle. Okay, now this is the filled out unit circle. Hopefully you have this constructed. If not, definitely make sure you go back to the previous 4 videos and see how you can construct the unit circle, because you're going to need to be able to do that. Okay, so remember that in the unit circle, that sine of theta is equal to y, and cosine of theta is equal to x. Okay, so remember, in the unit circle, this is true. Okay, so for example, we need to be able to evaluate trigonometric expressions of certain angles. So, for example, let's say I said, hey, what is cosine of 150 degrees? Well, cosine of 150 degrees is equal to the x-coordinate on the unit circle at 150 degrees, which is negative root 3 over 2. So, cosine of 150 degrees is negative root 3 over 2. All right, what if I said evaluate, let's say I said sine of, let's go with pi over 4. Well, remember, sine is the y-coordinate, and the y-coordinate at pi over 4 is positive root 2 over 2. Positive root 2 over 2. So that's kind of what I'm talking about by evaluate, okay? So it's real easy if you have the unit circle in front of you. However, we need to be able to do this without the unit circle in front of us, okay? That's kind of one reason I said it might not be a bad idea to kind of memorize some of this. Also, if you memorize your special angles, this is going to make it a lot easier. So if you remember that sine of 30 degrees is 1/2, and that cosine of 30 degrees is root 3 over 2. That's kind of what I'm talking about. Memorize that, okay? Now there's a couple of ways that you can help yourself. There's like a couple of things you can draw out that can help. The unit circle is obviously one of them, but that's a lot of time. I've seen tables, like for example, I've seen tables where people will put out like these special angles, and they'll have like a section for sine and a section for cosine. And then I see people kind of do this. Cosine of 30 degrees is root 3 over 2. Cosine of 45 degrees is root 2 over 2. Cosine of 60 is 1/2, which can also be thought about as a square root of 1 over 2. So if you notice, cosine kind of goes down, and if you look at sine, sine of 30 is 1/2, which could be thought about as square root of 1 over 2. Sine of 45 is a square root of 2 over 2. And sine of 30 is a square root of 3 over 2. I've also seen people kind of even put in 0 degrees and 90 degrees. So if we do that, I've even seen people do this where they put 90, and then it's kind of similar, except they start off a little bit higher. Now cosine of 0 is 1, which could be thought about as a square root of 4 over 2, because that becomes 2 over 2, which is 1, and then it kind of goes down from there. So if you notice, and then cosine of 90 is 0, which could be thought about as the square root of 0 over 2. Square root of 0, 0, 0 divided by 2 is 0, and then it kind of goes backwards for sine. So I've seen people do this, and that kind of helps them out, okay? And that's not a bad idea, especially if this kind of helps you start to memorize that, because ultimately these values never change. It might be very beneficial to just memorize them. I know I have. It's just ingrained in my head by now. Okay, so we need to be able to evaluate stuff like this without seeing the unit circle in front of us. So I'm going to scroll down, and we can kind of double check our answers. So let's say I wanted to know what, I don't know, sine of, let's say, 120 degrees is. Let's say sine of, let's say, 7 pi over 6. Let's go cosine of, let's say, I don't know, 225 degrees, and cosine of, let's say 5 pi over 3. Okay, and this is kind of the way I like to break it down in my head, and it sounds like a lot when it's actually outspoken, when it's in spoken words. Okay, but in your head you can kind of run through these calculations fairly quickly. Okay, so the way I think about this is I first think about what quadrant that angle is in. Okay, so for example, 120 degrees. Well, 120 degrees is in quadrant 2. I know that is because it's between 90 and 180 degrees. And I know in quadrant 2, sine is positive, so this is going to be a positive value. Okay, the next thing I think about is what the reference angle is. Okay, remember it's always an angle formed between the terminal side and the x-axis. Well, the reference angle for 120 degrees is 60 because I need to go an extra 60 degrees to hit the x-axis. And now I just do kind of what sine of 60 is. Think about what is sine of 60, which is the square root of 3 over 2. And if I check 120 degrees, sine is y, square root of 3 over 2. We got it. Okay. Now sine of 7 pi over 6. Now the radians might be harder for you to remember. Okay. Definitely get more comfortable with radians. 7 pi over 6 is a little bit more than 1 pi, right? 6 pi over 6. But it's definitely less than 1.5 pi, 3 pi over 2. So this is going to be in quadrant 3, where sine is negative. Okay, so I know this is going to be a negative angle. Okay, and now I got to think about what the reference angle is. Well, remember, if it ends with pi over 6, the reference angle is 30 degrees. Okay, which means now I'm just thinking about what is sine of 30 degrees, which is 1/2. And since we're in quadrant 3, where sine is negative, it's going to be negative 1/2. And if I look at 7 pi over 6, y is negative 1/2. All right, good. Go ahead and pause the video and try out these two. All right. All right, so hopefully you tried those two. Let's go ahead and take a look at both of these. 225 degrees, more than 180, less than 270. So I know this is in quadrant 3, where x is negative. So I know this is going to be a negative answer. And the reference angle for 225 degrees is 45. So I'm thinking, what is cosine of 45? Which is a square root of 2 over 2. So cosine of 225 degrees is negative root 2 over 2. If I check that out, boom, negative root 2 over 2. If I think about cosine of 5 pi over 3, well, 5 pi over 3, it's a little bit more than 1.5 pi. Okay, it's a little bit more than 1.5 pi. Definitely not more than 2 pi. So I know it's in quadrant 4. And in quadrant 4, cosine is positive. So notice the quadrant is telling me if it's going to be a positive or negative angle. And then I use a reference angle to actually perform the calculation. And remember, if it ends with pi over 3, the reference angle is 60 degrees. Okay, so now I'm doing cosine of 60 degrees. And cosine of 60 degrees is 1/2. Since we're in quadrant 4, cosine is positive, so positive 1/2. And if I check, boom, 5 pi over 3, positive 1/2 for x. Cosine is x, sine is y. Okay, so that's sine and cosine. One thing I want to quickly mention is tangent. Tangent's actually really important. So tangent of theta, well, that would actually end up being, if we think about it, I should probably use a better color. Tangent would be, so this is x, or excuse me, that's y. This would be x, this is theta. Tangent would actually end up being the y coordinate over the x coordinate, which can also be thought about as sine over cosine. This is very important. We're going to come back to this. This is something called a quotient identity. We're going to come back to that in a little bit. Okay, so let's actually go ahead and do maybe two tangents. Okay, so let's say I wanted to know what tangent of 30 degrees is. Okay, well, this is quadrant 1, where sine and cosine are both positive, so this is going to be positive. And I can think about this as y over x or sine over cosine. So the way I'm going to kind of think about this is sine of 30 over cosine of 30, 30 degrees I should say. And sine of 30, 1/2, cosine of 30, square root of 3 over 2. Oh no, got a fraction. We should be able to do this. This is just rational. Okay, I just want to multiply by the reciprocal of my divisor. So all that cancels, and notice the 2's actually cancel too. So this is going to become 1 over the square root of 3, which once I rationalize that would be root 3 over 3. And that's actually one that you can memorize too, because tangent of 30 and tangent of any angle that has a reference angle of 30 is going to be the square root of 3 over 3 every single time. Okay, you can kind of make a table similar to this for tangent as well, although it doesn't work out nearly as nice. Okay, so that would be tangent of 30. Say I want a tangent of, let's say, 3 pi over 4. Well, that's quadrant 2, where sine is positive and cosine is negative. So this is going to end up actually being a negative. Okay, and the reference angle is 45 degrees. So I'm actually going to kind of break this down. Oops, I'm going to break this down into sine over cosine. And I'm using the reference angle of 45 degrees. And because we're in quadrant 2, x is negative, so I'm attaching a negative to cosine. And what that would be, sine of 45 is root 2 over 2. Cosine is root 2 over 2. Well, negative root 2 over 2 because of the quadrant 2. And if you notice, this is the same thing. Everything cancels out here because it's all the same. This is just 1 over negative 1, which is negative 1. And that's actually going to be true for any for tangent of any angle that has a reference angle of 45. 45 is actually the easiest to do for all of them. Tangent of 45 is always 1, and then if you're in quadrant 2 or 4, it's going to be negative 1, okay? So make sure that we are practicing these, all right? And definitely make sure you're practicing it with the unit circle. All right, until the next video, goodbye.